Hello students, welcome to this session where we are going to discuss the physics analysis of the NEET test 65. I have solved this paper right now, and before moving on I'd like to thank you all for your love and support which has made this channel reach the 1000 subscriber mark in almost a month. Thanks for your love, thanks for your support, keep pouring in your support to me. Now in this particular paper, this is actually an easy paper. There were 21 very easy, 22 medium and 2 tough therefore, because 34th is a question based on laser which you generally don't study. It is based on the property that laser light is highly coherent. So the paper is quite easy, it's highly scoreable. I can say even a student who is practicing these tests, an above average student should get 140 plus, and a very good student, I say 165 or I say 170 should be the or higher should be the score of a student. Bearing this one question, all other are very easily solvable if you are thorough with your concept. So let's start the paper. Now the first one. In Bohr model of the hydrogen atom, the pair of quantities that are quantized. So what remains quantized? Energy and linear momentum. So the linear momentum is not quantized because the direction of velocity is changing. So A and B are false. We have energy and angular momentum because angular momentum is quantized nh by 2 pi, and energy is also 13.6 ev square by n square. So go for option C. Next. If lambda 1 and lambda 2 are the wavelength of the first members of Lyman and Paschen series, then, so for the Lyman, what we'll have 1 upon lambda 1, first member means that would be our 1 upon 2, 1 square minus 2 square, transition from 2 to 1, that is 1 upon 1 square minus 1 upon 2 square. For the Paschen, we have Lyman, Balmer, Paschen. Paschen is for third, that is from 4 to 3, that is 3 square minus 4 square. So what we have, so get lambda 1 by lambda 2, we have to divide the opposite one. So it would be 1 by 3 square minus 1 by 4 square upon 1 by 1 square minus 1 by 2 square. So it comes out as 16 minus 9, 7 by 144, and this would be what we can say 3 by 4. So it is 7 into 4 upon 3 into 144. So it comes out as 36. So 7 upon 108. So go for option D. Now the next one, third. A sphere of mass m moving with velocity v collides head-on with another sphere of same mass which was at rest. Ratio of the final velocity of second to the initial of the first sphere is, assuming E is the coefficient of restitution and collision is elastic. So first of all, what we will write, m into v plus 0 would be equal to mv1 plus mv2. v1 is the final velocity of first, v2 is the final velocity of second, and from the coefficient of restitution equation we will have v2 minus v1 is e times u1 minus u2, that is e times v. So these are the two equations we have. Now we have to get the value of the final velocity of the second sphere to the initial velocity of the first sphere. So these m goes cancel. So we have to eliminate v1. So if I write eliminate v1 from the above one, I can write it as v minus v2. That is equal to e times v. So what we will have, 2v2 is equal to e plus 1 times v. So v2 upon v is equal to e plus 1 by 2. So we go for option C, just simply using these two equations we can say. Next one. A bomb of 30 kg mass at rest explodes into two pieces, 18 and 12. 18 one goes with 6, the kinetic energy of the other. What you will say, the momentum of both will be same. So the momentum of the first one or the second one, P is equal to 18 into 6, that is 108 kg meter per second. And you know, kinetic energy of any part is P square by 2m. So for the other part, that is P square, 108 into 108 divided by 2m, that mass is 12. So 12 you have 9 times. This is 54. So 54 into 9, that will give me 486 joule. So I'll go for option B. You can do like that. You can also calculate its velocity and do. That is also a way. A particle of mass m is fixed to one end of a light spring of constant k and stretched length L. System is rotated about the other end with an angular velocity omega in a gravity free space. The increase in length. So what will be happening? So because it is rotated, so let's say this end is fixed, so let's say it will be stretched by some amount, and this would be the mass. So if it is stretched, it will become L plus x, and the force would be kx, and this kx is the centripetal force which is provided for its motion, that would be equal to m omega square r would be L plus x. So what we will have, x would be equal to m omega square L upon k minus m omega square. That is what we are going to have. This is a very standard question seen in the notes of almost all institutes. Next, the kinetic energy of a particle moving along a circle of radius r depends with distance like this. That means this is a non-uniform circular motion. Centripetal force would be, we know kinetic energy is half mv square is as square. So what we get, centripetal force you already know is equal to mv square by r. So from the above one, what we get, mv square is 2as square divided by r. So simply go for option D. It's simple like that. Next, the masses of 3 wires of copper are in the ratio this, and their length are in the ratio this. The ratio of their resistances. So the ratio of the masses is given, all are of the same material, and the length ratio is given. You know, because it is of the same material, the mass ratio would be the volume ratio, and volume is what? Area into length. So what we can say now, the ratio of the areas would be proportional to V by L. So let's say the first one volume be, let's say V, the third one be 3V, then the third one will be 5V, and let's say this is 5L, this is 3L, and let's say this is L. So the area ratio A1 is to A2 is to A3, that if I do, that would be equal to 1 by 5 is to 1 is to 5. That is, you can simplify as 1 is to 5 is to 25. Now resistance you know is equal to rho L by A, because rho is same, so R would be proportional to L by A. So again, going by the same analogy, what we will have, the first one area is 1 and the length is 5, that is 1 is to 5. Second one, what we have, okay, we have to do the reverse one, we would have been in trouble. This is 5 is to 1. For the second one it is 3 is to 5, and for third one it is 1 is to 25. So again, doing this would be 125 is to 15 is to 1. That is what I am getting. So go for option D. Simple ratio proportion you need to do. Next, 2 wires of equal diameters of resistivities are rho 1 rho 2 and length L1 L2 are joined in series. The equivalent resistivity of the combination is, so area is same, so what I can say, resistance of series is R1 plus R2. So this would be equivalent rho into length will become L1 plus L2 upon area remains the same A. Here it is rho 1 L1 by A plus rho 2 L2 by A. So going by the logic, the rho equivalent is rho 1 L1 plus rho 2 L2 divided by L1 plus L2. So we'll go for option A. Next one. In the adjacent circuit, the instantaneous current equation is, okay, so this is an LR AC circuit. So the voltage is like this. We know current will be lagging behind, and the lagging behind angle would be 10 phi is XL by R. XL by R is omega L, that is 100 into 1 upon 100, that is 1. That means phi is 45, so current would be 45 degree behind. So it would be that phase 100t minus pi by 4. You have two options. Now out of the, because 200t won't be there, so out of the two, now what would be the peak value? So what would be Z? Z would be R square plus XL square, because XL is equal to R, you got it 100, so it is 100 root 2. So what we have, I max would be V max by Z. So V max is 200, Z is 100 by root 2. So what it leaves me with root 2. So I'll go for option B. That is the most appropriate I can find out. Next one. Again the AC equation, in a series LCR, voltage across resistance, across inductor and across capacitor is given. So what we have, VC is greater than VL, it means XC would be greater than XL. That means the current is leading. So the voltage will be leading, wrong. Voltage drop across each element will be less than the applied voltage. Okay, so what would be the applied voltage here? Applied voltage we know is VR square plus VC minus VL whole square, that is 12 minus 6, that is 6 square, that is 10 volt. So voltage drop across each element will be less than the applied voltage. No, it is greater than that, so it is wrong. The power factor, that is what we write as cos phi. Cos phi is what we write as R by Z. So R by Z, if I have to do, we can have it like VR by V of source thing, you can write, that is 8 by 10, so that comes out as 4 by 5 now. So that is what we have, because the power factor is 4 by 5, so that is also not correct, so answer would be none of these. Next one, electric dipole kept on the axis of a uniformly charged ring at a distance r by root 2 from the center of the ring. The direction of the dipole moment is along the axis. The dipole moment is P, the charge on ring is Q, and the radius of the ring is R. The force on the dipole is near D. So what we have, this is a uniformly charged ring and dipole is placed like this here. Okay, the dipole moment is P, the charge on the ring is Q, this is P. Now here what we have, this distance is R by root 2, and I know the graph of the field versus X, if I draw this graph, is something like this. This has a maxima at R by root 2. So at this point what we can write, d by dx is 0, and whenever a dipole is placed in a non-uniform field, the net force on the dipole is given by P d by dr or d by dx here, and because d by dx here is 0, so force is going to be 0, so no need to calculate anything, because this is the result that you remember, that the field is maximum at x equals to r by root 2. Next, if the force exerted by an electric dipole, again a dipole, on a charge q at a distance of 1 meter is F, then the force at a point 2 meter. We know the electric field is due to dipole at large distances is proportional to 1 by r cube. So if you double the distance, the field become 1 by 8. So force will also become 1 by 8. Again, directly you can do. Next, body of mass m is placed at the center of the spherical shell of radius r and mass m. The gravitational potential on the surface is okay. So this is m, this is m, this is r. So what is the gravitational potential on the surface? So V at the surface due to himself is minus gm by r, and due to this point charge is minus gm by again r. So what we have now, we will have go for option A, easy one for you. Next one, the weight of the body at the center of the earth, you know that is 0, because at the center of the earth the gravitational field is 0, or the acceleration due to gravity is 0. So B option will be the answer. Body having a temperature of 27 degrees Celsius is kept in a room having a temperature of 27. Okay, so both are at the same temperature. Does the body emit any radiation? Yes, it will emit, but it will absorb the same. So therefore the amount of heat absorbed is equal to amount of heat radiated. So does the body emit? Yes, it will emit. You remember, every body at irrespective of every temperature always emits and always absorbs, and if emission is more, temperature decreases. If absorption is more, temperature increases. If both are same, temperature remains the same. Now next one, variation of internal energy with density of 1 mole of monoatomic gas is depicted. Okay, in diagram. Okay, the corresponding variation of pressure with volume can be depicted as, okay, so U is given as a function of P for with density, of 1 mole. It is for the, wait a minute, for the 1 mole of monoatomic gas. Okay, this is given. The corresponding variation of pressure with volume can be depicted as, so what we can write, because it is an ideal gas, it's basically T versus rho. You can take it like this. This is T versus rho. Now the curve, I cannot comment like, but it appears it is something like rho T is constant. It is appearing that rho into T is constant, and rho, what you can write is, so rho is 1 by V. So what we have, T by V is constant. So T by V is constant. That means if I have to draw the curve between temperature and volume, it would be a straight line passing through origin, and it means pressure is going to remain a constant. So pressure constant curve I can see only in which option? The pressure remaining constant with volume, plus what's happening? The density is increasing. So density is increasing, that means the volume we know is the volume is definitely going to decrease. So volume is not increasing, so B won't be there. It would be the D option. But again, they should have mentioned it. Okay, they have mentioned it. Okay, I didn't read it. They have mentioned that it is rectangular parabola. So my assumption was right. It was mentioned there. Next, the coefficient of performance of a refrigerator working between 10 and 20. So this is the question we are doing. This is QC upon W, which is QH minus QC, which is TC upon TH minus TC. We have done it many times. So TC is 283 and TH is 293 minus 283, that is 283 by 10, that is 28.3. That is what we can write. This is the option A we are going for. Next, proton and an alpha particle are projected normally with the same speed into a magnetic field. What would be the ratio of the trajectories, or the radii of the trajectories? So what we have, R is equal to what we have, mv by qb. So V is same, B is same. So proton and alpha, so R proportional to m by q. So R proton to R of deuteron would be, what we have, the protonic mass, we have 1:1 we can say, and for an alpha the mass is 4, charge is 2, so it will be 1:2. So go for option B, that would be the most appropriate one. Yes, next one. Now starting with again 19th, when a charged particle moving with velocity v is subjected to a field B, the force on it is non-zero. Because force is non-zero, that means V and B, the angle is not 0, not 180, so it is neither 0 nor 180, so it is definitely other than 0 and 180, that you can say, because for these two angles the force will be 0. Next one, the magnetic needle of a vibrational magnetometer makes 12 oscillations per minute. This is frequency, remember, in the horizontal component of earth field. When an external short bar magnet is placed at some distance along the axis of the needle in the same line, it makes 15 now. If the poles of the bar magnet are interchanged, the number of oscillations it will make per minute is okay. So first of all, it is 12 oscillations per minute. Okay, so the first frequency f1 we can rate, we know time period is 2 pi under root I by mb, so it is 1 pi upon 2 pi under root of mbh upon I. That is what we have, the first equation. That is equal to this f1, I put the value of f1 is 12. Now when an external short magnet is placed at some distance along the axis in the same line, it makes 15, so it increases, therefore b has increased definitely, so 15 would be 1 upon 2 pi under root of m bh plus b due to magnet upon I. This is the second one. Now if the poles are interchanged, so if it is interchanged, now the frequency would be 1 upon 2 pi under root of m, it would be bh minus bm by I for sure. This is the third equation. Now we have to find the value of that. Now how you are going to simplify this thing? So first of all, from the first equation I can write the value of mbh by I under root mbh by I, or mbh by I can directly write mbh by I can write as 24 pi whole square, and similarly mbh plus bm by I can write it as 30 pi whole square. Okay, so this is what we have got till now. So now I need bh minus bm. So for that bh minus bm thing, so what should I do? I should, let's say, multiply it by 2 and subtract it. So what I will get what I desire, mbh by I, mbh minus bm, sorry, bh minus bm by I, and that would be equal to 24 pi whole square, so it would be 25 pi whole square into 2 minus 30 pi whole square. So what it becomes 24 square is 576 into 2. 576 into 2 would be, what you will have, 576 is 550 is 1100, that is 26, so 1152 pi square if I am right, minus 900 pi square. So what you are left with, 252 pi square. So putting it, f would be 1 upon 2 pi under root of 252 pi square. So this pi goes, and this would be root 252 by 4, and if I do this would be 63. So this is a question requiring some calculation, simplification that I have done. You might do it some other way also, but this is the way I have adopted now. A body projected vertically upward crosses a point at a height h twice in its journey at t1 and t2 seconds. The maximum height reached by the body is. So this is a very famous question, subjective question. Now they have given it in objective, so let's try. So at a particular height, I know it would be at 2 times. This is given as t1 and this is given as t2. Now you have to find the maximum height reached by the body. So first of all, at both the instanted, what we know, it would be at maximum height at somewhere in between, and that time would exactly, I can write it as t2 minus t1 by 2 plus t1, because this is the t1 time and this is complete t2, so half of this difference added to t1, that is the time it would be at the maximum height, let's say at capital H, what I can write. Okay, so this is what we can have. So this time will come out to be, if I solve it, it comes out as t1 plus t2 by 2. So what we can say, so the maximum height, what we have, h is generally, what we can write is, h is half g t square. How we are writing it, I am reusing the equation. I can write it as the third equation. What would be the initial velocity? I don't know at this point, but between this and this point, final velocity is 0, acceleration is minus g, displacement is plus h, and time is t. So using the third equation, h is vt minus half gt square, so v is 0 and minus will become half g into t1 plus t2 by 2 ka whole square. So what we get now, so what the result will come out, the maximum height reached by this would be, it would I can write it as coming up with this, so it would be 4 to 8, so 16 to 8. So this is C option, that is the most appropriate, that is the answer that I can take for. Next, one stone is dropped from a tower from rest and simultaneously another is projected vertically upward with some initial velocity. The graph of the distance between the two, since both of them are in air, relative acceleration will be 0 because both are having g downwards, so relative velocity remains constant, so their graph would be a straight line, and of the available option there's only one straight line, that is option A. Go for it. Next one, block of mass 1 kg lies on a horizontal surface in a truck static coefficient friction is 0.6, acceleration is 5, the frictional forces. So what we can have here, we can determine the maximum safe acceleration for which it won't lose contact, that you remember is equal to mu sg, which comes out as 6. So it is safe, so it won't slip, and Fs would be providing the necessary force m into a, that is 1 into 5. It won't be 6 Newton, it would be 5 Newton, because that is what is required. 6 is the maximum magnitude that can act. This question I think we have done in some previous test also. Next one. A 8 kg mass is suspended through two light springs x and y connected in series. The reading in x and y, because they are in series, the reading will be same, tension will be same, and both will read the 8 kg. This is again a question on the same concept as been asked before. The particle emitted in this decay, just see, this is 92 to 92, so no change in atomic number, and this mass number is decreased. So mass number decreases by 4, that is 1 alpha. Because of 1 alpha, z should decrease by 2, but there is a 0, that means 2 is increased, so it means 1 alpha plus 2 beta minus, because beta increases the atomic number by 1, so 1 alpha and 2 beta are the answer for the part. Next, in the given nuclear reaction, x will represent, so simple, the total at the lower end and the upper end must be same. This is 4 and 2 6, so this is 0. 9 and 4 13, this is 12, so this is 1. So mass 1 and charge 0, that means it's a neutron. That's an easy one for you. Now, the time period of oscillation of a block attached to a spring is T1. When the spring is replaced by another one, it is T2. When both are connected in series and it is made to oscillate. So you just remember this particular concept. What happens here? In series, you know the effective K reduces, so time period will increase. So in time period of series is T1 square plus T2 square, that is the result you should remember. And for the parallel, we had 1 by Tp square is 1 by T1 square plus 1 by T2 square. Now how to get this? I'll just tell you what we can write. T1 is 2 pi root of m by K1. So I can write 1 upon K1 as T1 square by 4 pi square m. Similarly, T2 is 2 pi under root m by K2. So similarly, 1 upon K2 is T2 square upon 4 pi square m. Now in parallel, in series, it would be 2 pi under root m upon K series. And we know 1 upon K series is 1 upon K1 plus 1 upon K2. So going by the logic of the two, this 1 upon Ks can be written as Ts square upon 4 pi square m. This would be T1 square upon 4 pi square m. This is T2 square upon 4 pi square m. So this denominators get cancelled. Ts square is T1 square plus T2 square. Go for option B. Next one. The phase difference between the two waves represented by, okay, so these things are same. So this is the phase difference I am seeing, that is 0.5 is represented in seconds. So what would be in the second? So first of all, in terms of second, if I have to do, what should I write? Okay, I missed it. This is sine and this is cos. So be aware. So if I can write cos as sine of pi by 2 plus theta. So 100t plus pi by 2 plus x by 50. I can write x by 50 plus pi by 2 you can write. So this is pi by 2 and that is 0.5. The phase difference would be, what we can write, pi by 2 minus 0.5. That is 1.57 minus 0.5, that is 1.07. So this is 1.07 radians. We can go for option A. Next. The maximum kinetic energy of a photoelectron is 3 eV. Its stopping potential is 3 volt. There is nothing to be explained here. Next. From the following graph of photocurrent against collector plate potential for two different intensities. First you see stopping potential is same, that means frequency is same, and here the current is more, so I2 is greater than I1. You definitely know this. Higher the intensity, higher the saturation current or the current. Now the next one. A liquid drop having energy E is spread into 512 droplets of the same size the final energy is. So first of all, what we will have, because the drop is being split, so what we will say, first of all, liquid drop. So the volume we say of the initial drop is 4 by 3 pi r cube. That would be equal to 512 into 4 by 3 pi small r cube. Small r is the radius of the newer one. So 512 you know is the cube of what you can say 8. So 8 cube is there. So you can directly say r is equal to 8r, or r is equal to small r is r by 8. So now initially the energy was s into 4 pi r square, that is E. Now what would be the energy now? Energy would be s into 4 pi r square into 512. So that would be s into 4 pi. If I do r square, it will become r square by 64 into 512. So that becomes 8 times s into 4 pi r square. So that's clearly is 8 times E. So I'll go for option C. That is the answer. I'm going to take. Next. Body is floating in a liquid contained in a beaker. If the whole system falls under gravity, then the upthrust on the body due to the liquid is. So we did this question, okay, not for you, for the JEE main test yesterday. We say in the accelerated frame it is minus rho f v g minus a. So here a is equal to g. So this g minus a will become 0. So the buoyant force will become 0 in this particular case. So the answer would be A. Just remember, this is the buoyancy expression when the container itself is accelerated. Now, given that the velocity of light in quartz is given, okay, and in glycerine is given, if a slab made of quartz is placed in front of the object kept in glycerine, then the shift of the object produced by slab is. So we again did this same question, I suppose, for you, or might be for JEE main, whatever we can say. I can directly say that shift is equal to T 1 minus 1 upon n relative. What we can say, it is relative. So that n relative, I can write it as, I'll write now 1 n relative. First, from the data, you can say this one, n of quartz is equal to 2, and n of glycerine, if you do this, let me rub it. So n of glycerine, if you do, will come out to be 4 by 3. So what would be n relative? N relative would be 2 upon 4 by 3. So that comes out as 3 by 2. So if I solve it, T is 18. 1 minus 1 upon 3 by 2, that will become 2 by 3. That is 18 into 1 by 3. That will come out as 6 centimeter. So shift is going to be 6 centimeter. That you can do. We have done such question before. Laser light has the following property. It always lies in the X-ray region. It doesn't have unidirection. Doesn't have directionality property. It is white light. It is highly coherent. We simply say it is highly coherent. Again, you didn't study laser as such. It is not a part of syllabus. But this is being asked. You can't do anything. So laser light is highly coherent because of the process involved in its production that you will study probably in your college. So this question, I think, is not right to be asked for you, but if they have asked, I can't help. Next, particle of mass m, initial speed u, and angle of projection theta is projected as shown in the figure. Average torque on the projectile between initial and final positions p and q about the point of projection is, okay, average torque. So what I can say, tau average you can write as delta L by delta t. So about the point of projection, initial angular momentum is 0, and finally the velocity is like this. This distance is r, so we take the perpendicular component, that would be Vy. So that I can write it as m Uy, because Vy magnitude is Uy. So m Uy r upon t. So m Uy r is 2 ux Uy by g divided by t, which is 2 Uy by g. So what you have, 2 Uy g. So this 2 what we had, let me do it again. Let's say what we have, this 2 Uy and g by g goes, so what you have, mux uy. So I can write it as mu cos theta u sin theta, which comes out as mu square cos theta sin theta. I can write that as sin 2 theta by 2. So going by the options, it would be option A you can go for. Next one. On the application of a constant torque, a wheel is turned from rest through 400 radian in 10 seconds. So initially it was at rest, so directly I can write delta theta is half alpha t square. So it is 400 is half alpha into 10 square. So that is alpha is 800 by 100, that is 8 radian per second square. It's an easy one for you. I think we have done the same also some time back. If the ratio of the concentration of electron and that of holes in a semiconductor is 7:5 and current ratio is this, then the ratio of the drift velocities, we can directly say, whenever we are writing current, we know I is equal to NQAVD, where Q is the charge on the carrier. So both carriers have same charge, same area, so I would be proportional to N into VD. So I can say IE upon IH would be equal to NE upon NH into VD of electron to VD of holes. So electron, the current ratio is what you are given, 7:4, and concentration ratio is 7:5. So VD of electron to VD of holes, that ratio comes out directly, you can say, is 5/4 from here. So this ratio is 5/4. In the same ratio, it is 5/4. Next one. In the following common emitter configuration, NPN transistor with current gain 100 is used. This is the same question being repeated again and again. This is actually AV is beta RC by RB. You can write minus sign also, that's not needed here. AV is VO upon VI, beta is 100, RC by RB is 10 by 1, that is 1000, so VI is 1 millivolt into 1000, that is 1 volt. So go for this 1.0 volt. This is option C. This is third or fourth time I'm doing this in JEE Main and NEET papers of NTA. So they are not also finding questions, I suppose, after giving these 64, 65 tests in both. The coefficient of linear expansion of brass and steel are alpha 1, alpha 2. If we take the brass rod of length L1 and a steel rod of L2 at 0, then the difference in their lengths will remain the same at all temperature if. So what we need for temperature difference for the length difference to remain same, it simply means delta L1 should be equals to delta L2. It means alpha 1 L1 delta T equals to alpha 2 L2 delta T being same for both. So it is alpha 1 L1 equals alpha 2 L2. Again an easy one for you. Next. A public park is in form of the square has an area of this. The side of the park is, okay, this is a nice one. So we know area is a square or length square, whatever you can write small a square. So small a would be equals to root of a. So for the error analysis, I can say delta a by a is equal to half times delta a by a. Percentage term I can talk. So in percentage term, this is 0.2 by 100 and 200%. So it would be what is 0.2%. So it would be 0.1%. So the calculation error is 0.1%, and taking 100, the side comes out as 10. So it would be 10 plus minus 1.1%, that is 0.01. That should be the answer for this. Go for option A, because 0.1% of 10 is 0.01, you can write. Okay. Next one, in the YDSC, 12 fringes are observed to be formed in a certain segment when this light is used. If the light is changed to 400, what we know, fringe width is lambda d by d proportional to lambda. So the fringe width in both the cases would be 6:4, that is 3:2. So because fringe width is 2 by 3, fringe width become 2/3. So the number of fringes will become definitely 3 by 2 in the same section, because initially that was W1 into N1, now it would be W2 into N2, both should be same. So it would be reverse of that, so that would be 3 by 2 of the 12. So 3 by 2 of 12 would be that. Let's say you can write W1 N1 is W2 N2, that was I was saying, and that should be same, that is 1. So in the second case, N2 would be W1 by W2 into N1. So if you do that, W1 by W2, that was 3 by 2, and into N1, that was 12, that comes out as 18 fringes will now be seen in the same region. Okay, so you must have done such question. Numerical aperture of microscope is increased, then its resolving power, what happens to limit of resolution and the resolving power. Okay, so what we have, the resolving power or the limit of resolution, basically if we talk about, we had that formula 1.22 lambda something upon 2n sin beta if we had the oil of liquid n. Oh, and this thing was your we can say numerical aperture was this thing. So if the numerical aperture is increased, then what happens, the D will decrease, so limit of resolution decreases, and therefore the resolving power increases. So we'll go for option C in this particular case. Next one, a wave of frequency 500 Hz is a velocity of this, the distance between two nearest points that are 60 degree out of phase. So what we say, distance, so that would be k delta x. K delta x should be equal to pi by 3. K is what? 2 pi by lambda into delta x is equal to pi by 3. And what is lambda? Lambda I can write as V by F. So it is 350 by 500. So 2 pi by, if we reverse it, 500 by 350 into delta x should be equal to pi by 3. So delta x comes out as pi by 3 into 350 upon 2 pi into 500. So this pi goes, this 0 and 0 goes. So 35 upon 3 2s are 6. And is 6 into 50, that is what I can say, 300. So 35 by 300, that is I am getting, so 35 by 300 would be more than 11 centimeters. It would be closer to 12 centimeters. I can make it out. So it would be closer to 12 centimeter. That would be the answer. Not exact will not come. Now the 44, the direction of propagation of EM wave is given by E cross B. You know that. There is nothing to be told about it. The potential energy for the force field F is given by this, the force acting on a particle at a position vector given by. So we know force is equals to minus, because it is a function of two things. So first of all, I will write Fx is minus del u by del x. So if I differentiate it with respect to x, so cos will have minus again. So minus plus 1 plus. So sine of what we will have? X plus y only, because that is 1, so that would be fx. And similarly fy will also be sine of x plus y. You can make it out, del u by del y. So what would be the force at the point at coordinate 0 comma pi by 4? This both will be sine pi by 4, so it would be sine pi by 4 means it would be 1 by root 2 I cap plus 1 by root 2 j cap. Both would be positive, so I'll go for option B in this particular case. Okay, so the paper is over. So thanks for watching, and thanks for commenting and sharing my channel. And because of your love, it has crossed the 1000 subscriber mark in about a month, which is well beyond my expectation. When I started, in the initial 3-4 days, I was not getting that much views, but I kept on, and you kept on viewing, and you kept on supporting it. Thank you once again.